Welcome and thank you for joining us today. My name is Paul Donahue and I will be your host. We ask that you please keep your device muted during the session, and if you have questions, please direct them to me via the chat function. We'll do our best to answer the questions at the end of the session and to follow up with any unanswered questions via email. As I think you know, these tech talks have been designed to provide straightforward insights into radio frequency components, some of the related technology, and the extra design and engineering value that is added by custom manufacturers such as Quantic TRM and Quantic Corry. To begin today's session, I am pleased to introduce Eric Zacherl, Senior Engineer at Quantic Corry. In addition to being on the Quantic Corry team for several years, where he focuses on PCB design and switch matrices, Eric is a musician and a private school educator in the electrical engineering area. This diverse set of skills enables him to bring some unique perspective and analytics to his work. So, welcome, Eric. Can you share an overview of today's topic and your objectives for the session?
Sure. Thank you, Paul. And good day to you, and good day to everyone who's watching. So today we're going to talk a little bit about I/O filters, what they'll be used for, differences between them. We'll go through an example, and then we'll summarize everything we spoke about, and talk a little bit about Quantic Corry and the types of services that we can provide to you, our customers.
Well, that sounds terrific. So maybe to get started, what exactly is it that we need to understand about filters?
Well, so typically, in the RF filter realm, we have got various styles of filters, low pass, high pass, band stop, notch, all pass. And they are pretty self-explanatory. As you can see the graphic on the screen, and but today we're going to dive off at the end and talk about something a little different from these typical use cases. And I guess when we talk about the I/O filters, which I'm actually jumping the ship a little bit on here, they're going to differentiate quite a bit from these classical canonical RF type filters in a variety of ways.
Well, maybe you could tell us a little more about that.
Sure. We've termed these I/O filters because they don't filter out just a particular frequency. They filter out all undesired signals except for the I/O stream, which will pass through them. And that I/O stream is allowed to pass through them virtually without any distortion. And it does a very good job of blocking all other signals, as I mentioned, particularly wireless signals and wired signals that we may not care to see on the protected side of our device, or a filtered side of our device. So, and also, as you might be able to tell from the slides, that protection is bidirectional. So if the device that you're trying to feed clean data to is generating itself some noise, it will not pass it back through the filter to the other side. And this is good for both conducted and radiated noise. So you don't have to worry about anything external affecting the protected device connected to your filter, and also you don't have to worry about the end device corrupting anything on the outside of your filter, which is can be very beneficial if you don't want to have your lab or some other region corrupted by lots of electrically generated noise.
I see. And Eric, are all I/O filters the same, or are there different types?
Well, that's a good question. Yes, there are some different types. I'm going to break it down into two main types, and really there's some subcategories in between those. But there are two main types, passive and active. Passive filters, they have their place in the marketplace. They're typically less expensive, smaller. They're also very often not as good at blocking noise, and sometimes they'll load down the data bus, and so perhaps you wouldn't get the data rate that you would hope to get. Whereas in an active filter, you've got internal circuitry that's buffering your communications bus, and so it doesn't load down the filter, and it allows for really faithful transmission of the data that you want to get back and forth through the filter. And another key difference between the two is obviously a passive filter requires no external power source, whereas an active filter, you're going to need to provide power to it in some manner. So having two cables, one for the power and one for the communication bus may be necessary for you.
I see. Okay. Well, could you tell us a little bit about how these I/O filters are typically used in practice?
Yeah, I can do that. So, so they're typically paired with a shielded enclosure of some type, whether it be a desktop shielded enclosure, a large EMI chamber, or anechoic chamber, something of that nature. And they're mounted to the outside wall so that there is a pass-through, and that pass-through obviously allows for the communication to flow through in both directions to the device inside the chamber and whatever device you may have outside the chamber. And so it's commonly used for debugging radio frequency components, the design of those things, being able to analyze them in a quiet environment and pass the data back and forth to those radio frequency components without affecting their operation. And so the types of customers that we have that would like to use those things are, large RF test labs, RF product manufacturers. They might use them in their production testing or their qualification on their end. We have customers in the cellular field, for instance, that will qualify cell phones, other cellular enabled devices to run on their networks. And so they'll be able to run a gamut of tests on them that are designed to be run in the test chamber so that they don't corrupt the cellular network as it, because that would be pretty bad to have a device on the network and have it corrupt the network at the same time. So they want to verify that everything is operational before activating it in the field. And also digital forensics is a very large portion of the field. The reason for that is, everyone's carrying around a digital device of some sort that has RF connectivity, whether it be Wi-Fi or GPS or cellular. And, authorities would like to be able to isolate those things, keep hackers from getting at them, keep the criminals or, criminals or suspects, let's put it that way, rather than criminals, because they haven't been convicted yet, but keeps the suspected person, right? Innocent until proven guilty, and keep their goods shielded from being able to be accessed until such time as evidence can be collected from them. And really anywhere that electromagnetic interference is needed to be mitigated, and just keep a nice, quiet electronic environment.
Well, certainly those are some good examples on a general basis. Maybe you could share some specific product examples where we would see the I/O filters in use.
Sure. So here we have just a very simple drawing of a use case of one of the I/O filters. You know, it could be an Ethernet filter, it could be a USB filter, but in this case, it's attached to a PC, which is outside of the quiet space, which the quiet space being inside the enclosure. And in that enclosure, we have a device that's either under test or in there for forensic data collection. And there's a communications bus between that device and the I/O filter. And then between the I/O filter and the PC is that same bus, and the data can flow in both directions. And if needed, the device can be powered in order to, you know, keep it alive, in order, you know, so that it you know, the battery doesn't die on it, or it can just purely function. Okay, so here we go into one of our examples of a law enforcement digital forensic box. And this is something that one of our customers might manufacture and place filters on the exterior. As you can see, there are a couple filters on the exterior of this box, as well as some access holes for handling, and a port on top for visualization. And so, you know, this particular example, we're going to say that law enforcement needs to provide power to the device to keep it from going to its lock screen whenever it has to reboot. And it needs to prevent a suspect from accessing that critical piece of evidence. And so they place it in the box, close the lid, and it's effectively cut off from all network communications. And this allows the law enforcement community to you know, touch the device, see the screen, navigate through it, also connect to it, typically via USB if it's a cellular device, and pull any data off of it that they so desire. And so for this particular application, what's been chosen is a USB-C type I/O filter. And USB-C just gives you the most flexibility, and also quickest response time to getting it in the box, because you don't have to deal with that pesky USB-B cable trying to figure out which way to turn it over, right? Thank God for USB-C. It also allows it to over the USB-C to power the widest selection of devices, because USB-C can provide various levels of power.
Okay, well, that's excellent information, Eric. Thank you. Maybe you could summarize.
Sure. So, you know, these I/O filters are used for typical communication buses, you know, as I mentioned before, Ethernet, USB, HDMI, and also they only pass the data on the bus, and they block all other external noise sources. And well, as you can well imagine, the I/O filters aren't much use without a shielded enclosure of some type, because without a shielded enclosure, the noise would just transfer from one side of the filter to the other. And so, you know, that is a necessary part of the equation. And, you know, different levels of filtration exist, you know, whether you need a high amount of isolation if you're an RF test lab and you really need to get those last decibels out of your measurement, or whether you're just I don't know, a hacker in your garage and you want to keep your garage door opener from talking to whatever's in the box. Something of that nature might need a lesser level of filtration. And, as we talked about, the delivery of power through the filter is also possible. And that just eliminates another leakage path that could exist if you did not have that power filtration.
Okay, well, thank you. And maybe could you speak just a little bit about Quantic Corry and maybe some of the differentiators associated with their approach to the marketplace?
Okay. Well, so we work a lot with our customers to provide the level of service that they require, and whatever components, whether it's a small one-off component or whether it's many hundreds or thousands of components that you need for your project, Quantic Corry will support you in whatever manner you require. We service the industrial, aerospace and defense, medical, forensic, many other markets. We can satisfy those requirements that you have. And we have our own machine shop, so we have unique capabilities in terms of being able to provide electromechanical solutions for our customers. And when it comes to reliability and test compliance, we have the capabilities that our customers are looking for. And we provide total solutions to our customers and not just a piecemeal approach. We'll work with you hand in hand to make sure that your project is a successful one.
So it's more than just providing components.
That's right. Yeah, we provide components, we provide expertise, software. We are really focused on the customer's needs.
Excellent. Well, thank you. And I think we have time for one question. And you had mentioned earlier that some of the differences between active and passive. And why would somebody choose a passive filter instead of an active one if the passive ones are not quite as good?
Well, so cost would be a big reason to choose a passive filter. The passive filters typically are a little less costly and smaller, but they do not provide the isolation that an active filter provides, and they have their drawbacks and they have their places. If you don't need a high level of isolation, a passive filter may be for you. But if you need the high levels of isolation, you need to deliver power, you need full bandwidth on your data bus, then an active filter is probably more suited for your application.
Okay, that makes sense. Well, thank you again, Eric, and thanks to all of you for joining us today. I think in conclusion, the bullets on your screen say it all. If you are a customer and you have additional questions, or if you'd like to discuss an application with one of our engineers, we'd love to hear from you. Please call our engineering hotline. The number is on your screen, 724-940-7556, extension 276. There are no costs, of course, for these conversations. And if you are one of our field service reps, then of course, or field sales reps, you know that your calls are always welcome too. Going forward, our next Tech Talk will be on Tuesday, September 26th at 1 p.m. Eastern, and the topic will be switch matrices. Thank you again, Eric, and thank you, everyone.
Thank you, Paul.